The area of mechatronics and the melding of microcontrollers has been going on for quite some time and is becoming more and more prevalent and more popular. One of the areas out there is in the area of unmanned aerospace vehicles, UAVs, UASs, and quads, and some even call them drones, where we have flying machines as well as machines that roll on the ground, but the flying machines that are able to do some phenomenal things in terms of taking off, taking pictures, going out to waypoints, returning by themselves, landing by themselves. And all of this is due to the prevalence of microcontrollers, the writing of good code to control the microcontrollers on board the quads and the UAVs. We're going to see a little bit of that in the course. We're actually going to let you touch and play with a UAV that we've purchased, and we'll get to that. But right now, let's do an introduction of the mechatronics and microcontroller marriage. It's playing a major role in an emerging field called mechatronics. Many technical processes and products in the area of mechanical and electrical engineering are showing an increasing integration of mechatronics with electronics and information processing. This integration is between the components hardware and the information driven functions, the software, resulting in an integrated system called the mechatronic system. So with this course, what we're looking at doing is bringing that all together for you, to see it. You've had lots of electronics courses in your background. You've built lots of circuits. You've done some things with solid state devices. You've done some things with the passive devices. If you've taken the data acquisition course, you've actually played with the Bobot and written some code for that. So you've had an introduction to it. So what we want to do is build upon that and have some fun with this course and where it can take you. The development of mechatronic systems involves finding an optimal balance between the basic mechanical structure, sensors, and the actuator implementation, automatic digital information processing, and overall control, and this synergy results in innovation solutions. So as you're going through this course and you're looking at these things, start thinking outside of the box. Don't get intimidated by the writing of the code and the software, because this is all part of the process of understanding microcontrollers and their embeddedness in mechatronics. The practice of mechatronics requires multidisciplinary expertise across a range of disciplines such as mechanical engineering, electronics, information technology, and decision-making theories. So this is all starting to come together. For those of you out there working in the real world already, you've probably seen some of this. Those of you that have not, it's going to be a great introduction for you in understanding how mechatronics and the disciplines come together. So the next thing we'd like to do is, and I'll do it in the next video, is take an overview of the PIC family, the PIC microcontroller, because that's what we're going to be looking at in this course, and trying to understand the writing of code and understanding the architecture and the interfacing of a PIC 18 microcontroller. And so we'll pick this up in the next video.